Okay, let's do this exam question from the final paper in November, December 2015. The way they ask you these questions, they want you to recall information. Okay, recalling information is one of the biggest factors when answering these questions. Okay, let's go ahead and say the track of a motorbike race consists of a straight horizontal section that is 800 meters long. A participant such as the one in the picture above rides at a certain average speed and completes the 800-meter course in 75 seconds. To maintain his speed, a constant driving force of 240 newtons acts on the motorbike. Calculate the average power by the motorbike for this motion. Okay, marks. Okay, remember power is equals to either work over time or power is equals to force multiplied by velocity. We know that velocity is distance over time. We have 800 meters divided by 75 seconds, which gives us the speed at which the participant was moving at. That gives us a speed of 10.67 meters per second. Now, we can now come back to this formula and say what was the average force, sorry. Let's go back here. The force was 240 newtons. So we can say that 240 newtons multiplied by 10.67. Remember to round off to 2 decimal places. 10.67 multiplied by 240 will give us 2,560.8 watts. Happy? Recall. This is how you're gonna win in those exam questions. Okay, let's continue. Let's go again. Let's go. Now, okay, what I want to do, I want to adjust so that we can see the rest of the question. Okay, stop it here. Okay, we've calculated the power. Okay, now there. Okay, and I just want to open that up like that. Okay, now another person practices the same motorbike on a track with an incline, starting from rest, and the person rides a distance of 450 meters up the incline, which has a vertical height of 5 meters. Okay. Now, what I would say for you to do, right? You're in the exam, you know that what they did now, they didn't give you an angle and they're trying to catch you off guard. Obviously, there is more than one way to solve this, but what you can do, you can just do a little drawing for yourself there, right? You know that there's 90, you know that's 5, and then you know that's 450. You can use a sign of the angle to say opposite over the hypotenuse, right? And then you can calculate the angle of 5 over 450. Okay, you can calculate that angle. of 5 over 450. So I think this would be easier rather than trying to work with the ratios. So we know the angle is 0.64. So that's what theta is. Okay, let's go back, collect some more information. Now, what you have just done, you've added theta, right, to your diagram. Okay, a total frictional force acting on the motorbike is 294. The combined mass of the rider and the motorbike is 300 kgs. The average driving force on the motorbike as it moves up the incline is 350 newtons. Consider the motorbike and the rider as a single system. Okay, so gotta consider their mass as one whole mass. Okay, that's pretty simple. Now, draw and label a free body diagram. Okay, go there. Gonna come here. We're gonna say this is the bike. It's moving up the incline at force applied. Behind it, there is frictional force. Weighing it down is weight, and this is Fn. Then I'm going to say Fn is equal to the normal force, right? Ff is equal to frictional. Fa is equals to force applied. Okay, and W is our weight. Okay, you should get all of your marks if you do it like that. Okay, now state the work-energy theorem in words. Knowing your definitions. If you do not know your definitions, you're literally throwing marks away in the exam. You know, this is an easy way for you to collect marks. Okay, the work-energy theorem states that work done on an object by a net force is equal to the change in the object's kinetic energy. It is literally the formula of the work-energy theorem. That's what the work-energy theorem is. Okay? Now, use energy principles to calculate the speed of which the motorbike at the end of the 450 meter ride. Now, normally what they want you to do is that when they ask you a question like this, state the work-energy theorem, they are hinting to you that they want you to use the work-energy theorem in order to solve these questions. Remember though, you are not prohibited to not using any other formulas, right? You remember in the first question we used the speed formula. The speed formula is not taught in your work energy power section, but you may use it. Now, what I want us to do, what we're going to do now, we're going to come here to our page, right? Okay, and then let's get rid of this. Let's get rid of this. Okay, and we get rid of this. Okay, and we get rid of this. Now, get rid of this as well. Okay, I think it's best if, okay, we know theta is 0.64. Okay, what else do we know? We know that the frictional force is 294. Okay, we know that the force applied by the engine is 350. Okay, remember with Newton's laws, every time we're moving at an incline, F parallel works against or assists. Either it's going to help you or it's going to work against you, right? So we need to calculate what F parallel is. So F parallel is obviously weight sine of the angle, okay? Which is, what is the weight? The total weight is 300, okay? So we say 300 multiplied by 9,8 multiplied by sine of 0,64, which will give us F parallel. 300 9,8 sine of 0.64 will give us 32.84 newtons. Okay. Now, I'm going to write a formula here, and I'm going to say the total work done is equals to delta K, kinetic energy. Okay, now we need the total work done. But here we have all the forces, right? So we can say that F net is equals to F applied plus F friction plus F parallel. We know that F applied is 350. Friction is working against 294. F parallel is working against 32. We get our F net to be 23.16. Okay. That's our, what is that? That is our net force. Okay, so when I raise this, you saw how we need to calculate our net force. Okay, now I want to write this here. So F net equals to 23.16. Now if I have F net, this means I can calculate W net. So W net will use the formula of delta x cos of the angle, which is 23.16 multiplied by 450 times cos of 0.64. Sorry, don't know why I'm writing like that. So the total, so now we're calculating the total work done. So the total work done in the system is 10,421.35 joules. So we calculated F net. We used F net to calculate the total work done. Okay. Now we can come back. We can use this here. So we draw a line here. Now what I'm going to say F net is equals to EK final minus EK initial. Then I'm going to plug all of this. I'm going to say we need the final speed, right? So I'm going to say a half mv squared final is equals to work net plus a half mv initial. But remember, let's go back to the question. Remember, the motorbike combined frictional, okay, wait, somewhere there. This person started at rest. Look at the first statement. Another person presses on the same motorbike on the track with an incline starting from rest. So we know that the initial velocity is 0, right? So that's 0. Then we can say that v squared, is equal to work net divided by a half m. So v will equal to the square root of 1421.35 divided by a half of 300, which will give us 8.34 meters per second. And that is how you calculate and solve an exam question using what you've learned from your work energy power.